Here's an example video for the topic Finding the Domain of a Fractional Function Involving Radicals. In this video, we will look at the function f of x equals the square root of 8 plus x all over 1 plus x. Our goal is to find the domain of this function, and the domain is a set of all x values that make square root of 8 plus x over 1 plus x a real number. Our first step is to look at the numerator, square root of 8 plus x. In order for a square root to be a real number, it must always be positive. So in this case, 8 plus x, start inside expression, must be greater than or equal to 0. And doing some simple algebra, we see that x is greater than or equal to negative 8. So for now, our domain is negative 8 to infinity. Now our second step, though, is to look at the denominator. We see 1 plus x. If the denominator is equal to 0, then it's not a real number. So we'll find where 1 plus x equals 0. We see that 1 plus x equals 0 at x equals negative 1, which means that at negative 1, square root of 8 plus x over 1 plus x is not real. And so therefore we have to remove negative 1 from our domain. This is also in a graph called a vertical asymptote. There's an imaginary barrier that the graph does not touch. So our final answer for our domain would be negative 8 with a solid bracket because negative 8 is included in the domain, to negative 1 in parentheses, because negative 1 is not included in the function because it's a non-real number in this case. This is united with negative 1 to infinity to complete the domain. And a graph would look something like this. We start here at negative 8, and then it goes on towards negative 1, but doesn't actually touch negative 1. And then it continues up here, going this way, out to infinity. And this shows where negative 1 is not included, and negative 8 is included, and it goes all the way out to infinity. And that's how you find the domain of a fractional function involving radicals.